I want to make an eye chart which you can use to measure your eyesight at home.
Somebody had to do it.
This is what I'm talking about. It's called a Snellen chart. Now, the problem with all of these is they're meant to be used at a different distance. How does one go about making their own Snellen chart? Now, that's a good question. I have no idea. The distance at which the smallest optotype identified subtends an angle of 5 arc minutes. They give it a formula, but I'm not really sure I understand it completely. I have no idea. Okay, I feel so dumb because I was using degrees to calculate the formula, but obviously you have to use radians. And 5 arc minutes is equal to this amount of radians. And if I run this is my answer. But this is in meters, and I just need to convert this to millimeters. So meters to millimeters. What the fuck? I'm getting 87.3 millimeters. Okay, so I finally understand how the formula works, and I guess the next step is just to start designing. So my goal would be to replicate each of those optotypes. There you go. So that's the letter E. So we have an F, we have a P. I have no idea how I'm gonna create the O and the C. 256 on the inside. Boom! Yeah! There you go, that's the letter O. So you might be asking, why can I just reuse these instead of creating my own version of it? Because this one is not perfect, this one, and I'm making this one, which is gonna be perfect. And none of these are perfect, but mine's gonna be perfect. This looks so bad, the original, because this is not even a 5-point grid if you think about it. Ooh, nice. I have no idea how to. There must be a way to calculate the angle at which I have to rotate this piece, but I'm too lazy to figure out the trigonometry of that, and I'm just gonna eyeball it. Oh, no way. I might have an idea. Wait. Oh, what the fuck? I know that this is 256, and I want to calculate these sides. Why doesn't it make sense? Wait, Alright, so finally I have all of them good to go, and next step is to start designing the actual eye chart. Man, closing all of these tabs is so satisfying. Right, so I just measured the distance from this wall to this wall, and it's 15 feet. And I'll be putting the eye chart on this wall. So in the classic version of the Snellen, it goes from 20/200 all the way down to 2010. I kind of want to focus more on from 2050 to 2010, I would say. So I want to try and explain how all of this works. The first number is you, and the second number is the average person. So 2020 means you are the same as the average person. 2040 means your eyesight is worse than the average person. 2015 means your eyesight is better than the average person.
I mean, I don't know if you're going to put this on television, but you don't even know what you're talking about.
So as we already know, the height of the 2020 row should be 8.73 millimeters. There's going to be some sort of a scaling factor. 8.73 times 0.75, and it's going to be 6.5 millimeters. So now how are we gonna go about so now that we have the baseline, we can calculating the letter
Anyway.
So now if we know that the baseline is 6.55 millimeters, we can go ahead and start calculating the other rows. 2040 is 2 times scale factor, so this is gonna be 6.55 times 2. I am working with pixels inside of Figma, but all of my measurements are in millimeters. I need a way to convert millimeters to pixels, and this is gonna depend on the DPI of the page. 792 divided by 11 inches. So this means we are working with 72 dots per inch. I can use the scale tool inside of Figma to basically scale the baseline row. Okay, so this is what I'm talking about. I have the 2020 row as baseline, and let's say I want to generate the 2050 row, which is 50 over 20. This is 2.5. Copy the 2020 row, and I'm gonna do 2.5 scaling, and boom, just like that, we have the 2050 row. What I'm doing right now is super boring. I have to just move them around so that I create random sequences so I don't memorize it. Let me give it a shot. I think this might work. Okay, so this is pretty much good to go. I need to export it real quick. I'm gonna do PDF. Woo, it looks nice. Okay. I got my first version of the eye chart ready, and I just realized I don't have a printer. Yeah, so right now it's 6:17 and they close at 7. So like, imagine if this works, yo. Okay, so this was an epic fail because for some reason the printer could not read the document. I guess I exported it like wrong. I have no idea. So I just got back and I'm trying to see what's wrong with the file. Yeah, I don't know. Okay, so this is how it turned out. I've added the reference lines. This is 2050, 2040, 2030, 2025, 2020, and 2015. Yo, it's the next day, and today I'm gonna try again to print the eye chart.
Oh shit, here we go again.
Okay, so I got a test lens kit. So this is what they have at the optometrist, and I got a bunch of different like lens powers. This is how it works. Get whatever lens power you want and you just pop it in like so. You can adjust the axis of the cylinder. You want to make sure you have good amount of natural lighting. Okay, so right now I'm 15 feet away from the eye chart and I can see the red line pretty clearly, which is the 2020 line, which is baseline, and I can just barely make out the next line, which is the 2015 line, which means the eye chart is perfect. So the eye chart turned out pretty well. Next video, I'm gonna start writing code so you can generate eye charts for pretty much, you know, every distance you can possibly need. So make sure to stick around for that one.
Do I like doing that? No, I'm a nice person, believe it or not. I mean, I have a heart.